Thanks, guys. I've set my own timer, so hopefully I'll get this done. So that speaks for itself, but there's a bit of jargon to explain, maybe. That works okay. So jargonology is my term for the conference, and so because I've got two presentations and they both have jargon in them. So both of these things here, we're looking at solar self-consumption. It's often considered to be a rational economic response to solar power being cheaper, free, than drawing power from the grid. What I'm going to look at here is what happens when there's no price signals. Solar rebound has been found to is a phenomenon where people use more power overall because they have access to solar power because it's free. So what happens, but what if electricity use increases during the day when there's plentiful supply of solar and decreases at night when we normally have problems with demand? That would change solar rebound from being perceived as a negative to a positive within the energy system. So the context for the study is Australia has huge amounts of rooftop solar. We lead the world by the mythical country mile. The problem is there's so much of it in the middle of the day, it floods the system when no one really wants it. And so it causes problems with the system, it can cause blackouts, etc. So increasing solar self-consumption can keep electricity prices down, essentially because it means there'll be less need to invest in very expensive electricity system infrastructure in order to stop the blackouts happening in the middle of the day. Small picture is a solar and battery program in a remote Australian town. They had a very strong focus on financial incentives, as you can see. But uniquely under this program, there were some corporate landlords who pay their tenants' bills, and they also paid to install solar systems for their tenants. So these households faced absolutely no price signals and had no engagement directly with the program at all. So what I'm interested in exploring here is what happens when they have no financial incentive. Do we see solar rebound? So research that's been done, typically households use 20% more overall after installing solar. No research that I'm aware of has used smart meter data to explore the time of day impacts of installing rooftop solar. And no research has explored the difference in solar rebound in the presence and absence of price signals. So what are the time of day impacts of installing solar on household electricity use, and does solar rebound occur in the absence of price signals? So I used quasi-experimental method of difference in difference regression analysis, propensity score matching to create a quasi-control group or a comparison group of households. The households were from a nearby town, as opposed to the same town. They had absolutely no exposure to the program, and they didn't install solar over the period of time we're looking at. And a group in Canberra called Energy Fit Homes, who have an excellent modelling capability for solar generation, actually modelled the solar generation of the houses over that period of time in this town. I didn't have access to actual solar generation, so that'll come up in my limitations if I get as far as that slide. So the treatment group comprises 67 households who installed solar through the program. 46 faced price signals and 21 did not. And my control group is 823 solar households who were matched on their electricity use prior to the electricity use patterns prior to the solar program being launched. These charts just show at key points of time in the day that the bottom two lines there in each of the quadrants are the treatment group and the comparison group, and showing that the weekly averages at the different times of day, their energy use, their electricity use tracks each other very, very closely. Important here, this method don't have to be exactly the same, just the differences need to be the same. And I back this up with regression analysis that demonstrated that there is no statistical difference between those two groups. The line across the top of each of those charts are the households that were not included. You see there's quite a big difference there. So the matching we said is appropriate to use this method. So what did I find? So what we get from this, so in the left panel there, we've got just a general before and after consumption. So I've translated the regression results into simple charts because I find showing charts, it makes it very hard to explain what's going on. So this is a kind of a background trend of an increase in daily electricity use from households that weren't involved in the program, but had similar electricity use before. We do see that we have quite a significant amount of solar rebound going on, both with the price signal and without the price signal. And so, in fact, that the overall daily electricity increased by 33% where there were price signals and 24% when there were not. So that's just overall over a 24-hour period. Now, when we look at just through the daytime, we're seeing a very large increase in electricity use there. Again, there's a background trend of increasing, but for households with a price signal, they actually increased their use during the day by 50%. So it's a massive increase, way beyond that 20 that's been found as an average across the whole of the day, and often considered to be uniform. And with those that didn't have a price signal, they also increased by 41% in that period of the daytime. Interestingly, overnight, again against the background of an increase, the households that put the solar on, and I think this is contrary to a lot of assumptions about solar rebound, they actually used less in the evening. So we're actually seeing what might be considered a very rational economic response. They have shifted their use to when it's free, and they're using less at night, which is generally not the assumption that people make. A really key point of time is after solar has stopped generating, but we're still in a peak demand for electricity use. And again, we see that there's been a decrease here for both groups over that time. So, with regard to time of day, solar rebound, it supports other research. We do have of solar rebound and overall electricity use, but it occurred only during daylight hours. So potential implications for electricity demand forecasts, which dictate how many billions of dollars get invested in the electricity system, and that flows through to all of us as electricity prices. This is called the duck curve. I don't know if anyone's come across that. It looks a bit like a duck. And so what's happening here is that the projected changes, this is the projected changes in electricity demand over the time of day in subsequent years. And we see the hollowing out during the day is getting bigger, and they're predicting an increase in the peak as well. So what we can see here is that if evening peak is actually projected to go up, this study shows it going down. Also, a 50% increase in daytime will go a long way to stopping that hollowing out happening in the middle of the day as we get above 30 towards 50-60% of households with solar, if they behave like these people did. So, solar rebound without price signals, it happened. So these people had no price incentive whatsoever to change their energy use, but nonetheless they did. And they followed the same pattern, slightly muted. So I'd say about 2/3 of the effect was not related to the price signals in this case. So non-financial factors have a substantial influence on electricity use behaviour. Limitations is a small sample, but the data set was extremely rich. I had 15-minute interval smart meter data over the two periods of time. All the results were very strongly statistically significant. It was not your average bunch of Australians living in a remote Australian town. All the conditions, it was very hot. So, that's to be taken into account as well. We don't know if other people would behave the same. And the model solar generation isn't perfect. It would have been much better to have the actual solar generation on those days, because I can't take account of minute-to-minute weather conditions. You're right, it's time. And that's it. That's when I ditched. Excellent.